Hey guys, today we are going to look at one more formula, and as you guys might have noticed on our scavenger hunt, there were a couple questions that were asking us to find the area of a triangle. And to do that, we had to kind of revert back to our classic formula that we know, which is the 1/2 base times height. Right? So for some of the problems, it took a couple steps because we had to find that height, right? We had to use law of sines, law of cosines, find a missing side, find a missing angle, and then go again to find the height of the triangle. So what we're going to look at today is kind of an interesting equation that's actually derived from law of cosines, and this will allow us to find the area of a triangle if we know all of the sides of that triangle. All right, so remember when we label a triangle, okay, we use our capital letters to represent the angles, and directly across from each angle is its corresponding side. So if right here is angle B, let's try that again. All right, so we have angle B, then directly across from angle B is going to be your side B. All right, so we've got to be comfortable with labeling the angles and sides of our triangle. All right, directly across from angle C is going to be side C, and of course, directly across from angle A, we're going to have side A. All right, so the formula that we're going to use today is called Huron's formula. All right, and once again, it allows us to find the area of an oblique triangle without having to find the height. It does use all three sides of your triangle. All right, and so this formula states that the area equals the square root of s times s minus a times s minus b times s minus c. All right, well, we know what a, b, and c are. Those are the sides of the triangle. That's what we just looked at. So we've got to look at, well, what's this s variable that's in our equation? All right, and so if you look right underneath it, we have an equation for s as well. S is going to represent the semi-perimeter of the triangle. Right? Think about a semicircle for a second. It's half a circle, right? So the semi-perimeter is half the perimeter, right? To find S, we add up all of the sides. So we take A plus B plus C, and we multiply it by 1/2, right? Or you can think of it as dividing it by 2. We find half the perimeter of the triangle. That's going to be the first thing that we do when we use Huron's formula, right? We'll solve for S. Once we have the semi-perimeter, we're going to go to that area formula and we're going to use the square root of, and we'll plug it all in, right? S times S minus A times S minus B times S minus C. So if we look at an example of how this works, okay, we have a businessman wishes to buy a triangular lot in a busy downtown location. The lot frontages on 3 adjacent streets are 125, 280, and 315 feet. We want to find the area of the lot. So if you remember Huron's formula, right, to find the area, the first thing we need to do is solve for S, right? So Huron's formula tells us that if we want to find the area, we take the square root of S times S minus A times S minus B times S minus C. All right, so the first thing we definitely need to do is solve for S. So to find the semi-perimeter, we're going to take all the sides of the triangle, which is going to be 125, 280, and 315. We're going to add them all up and divide by 2. So when we add up all those sides, we do end up with, if I can get my pen to write, there we go, 720 divided by 2. And if we do go ahead and actually do that division and divide by 2, we end up with S equals 360. Now that we've found S, we can go ahead and use our area formula. All right, so all I'm going to do is I'm going to plug in my S, my A, B, and C. Plug in my 3 sides of the triangle and plug in S as well. So when I plug it into the formula, I do end up with the square root of 360 times 360 minus 125, 360 minus 280, 360 minus 315. Now that you have it in your formula, you've replaced all of your sides. Okay, we've plugged in A, B, and C. We've plugged in that S. All we have to do is calculate. So we can go to our calculator and type it all in. All right, I would type it in all at once, square root of, and put everything underneath that radical. When we go ahead and solve for this whole equation, we should end up with approximately 17,451.6. All right, now remember that this is a word problem, so we're going to go ahead and put our answer in a complete sentence. All right, so oops, I'm going the wrong way. All right, if we want to buy this plot, we can say the area of this plot is approximately 17,452 feet squared. And there's our solution. All right, so this works whenever you know all three sides of your triangle. All right, you can use Huron's formula. You've gotta have all three sides of your triangle in order to use it. So that leads us to our second area equation, right, that we can use if we don't necessarily have all three sides of our triangle. So the next one that we have, we're going to write down in our notes, is area equals 1/2 B times C times sine of angle A. All right, you'll notice, once again, this is going to be like law of cosines, where we have three different formulas, but they're all essentially the same formula, just solving for different sides and angles, depending on what you're given. All right, the next one we have is area equals 1/2 A times C times sine of angle B. And the last one we have is area equals 1/2 times AB sine of angle C. So if you notice, you don't need all three sides of the triangle in order to use this formula anymore. All right, this formula works whenever you have side angle side, or you have two sides, okay, like B and A, and then their interior angle. All right, you have side AB and angle C. And it doesn't matter which formula we look at, it's all going to be the same way. If we look at this top formula, we have sides B and C. Right, so sides B and C, and the interior angle, angle A, side angle side. We can use this formula. All right, so let's go ahead and do a practice problem with it. All right, so the first thing I'm going to do is I'm going to identify my sides. All right, so 7.4 is directly across from angle S, so this is going to be side S. Right, and we have side T, right, and we have angle R. So we have side angle side. We can find our area by taking 1/2 times T, right, times S times sine of angle R. Right, so really all we have to do is plug it into the formula. So we know that side T is going to be 11. So I'm going to replace this T right here with an 11. Now my S value is 7.4, so I'm going to go ahead and replace that S with a 7.4. And the last thing I need to do is plug in my R value, right, which is 52 degrees. So now all we need to do is go ahead and plug it into our calculator. Right, always check to make sure that your calculator is in degrees. As long as it's in degrees, we're going to just plug it right in. 1/2 times 11 times 7.4 times sine of 52. And we are going to end up with an area right? That's equal to 32.1. All right, now we do need to put this in some context. This is an area, so it is going to be in kilometers squared. And there we go, that's our answer. So let's go ahead and try one more. All right, I'm going to give you a second. I want you guys to try to answer it on your own. And then we'll look back and compare. While you guys are working on it, I'm just going to go ahead and put the formula up. Okay, so once you plug in your sides and your angle, you should have ended up with 1/2, 4 times 5 times sine of 56, right? And when we calculate that all out, we do end up with approximately 8.29, right? We need to make sure we put the units on it, so I'm going to say miles squared. All right, if we were to round it to the nearest tenth, we would end up with approximately 8.3 miles squared. And there's our answer. All right, so what I'm going to have you guys do now is I'm going to have you go into Blackboard and you'll see an area of a triangle assignment under Unit 3, right? And that's what you're going to work on. So remember, when we have side, 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 we can use Huron's formula, right? And when we have side, angle, side, we can use our area of a formula, which is 1/2, okay, A times B times sine of angle C. Okay, that's when we have side, angle, side. Now, if we don't have side, 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 or side, angle, side, keep in mind you can use your law of sines or your law of cosines to find a missing side or to find a missing angle, so that way you can go ahead and find the area of the triangle. All right, feel free to email me if you have any questions. I'll see y'all later.